log, which you can. Now why not just take the log of each side? Introduce the log on each side. Another strategy. Place a log on each side. And then on the left, you could move the x out front by using the what? Power property we talked about on Monday. And have x log 3 is equal to log 14. And then divide through by what? Log 3? Hang on. Do we get that? And by the way, Shane, this was the original, wasn't it? Solve for x.
Yeah.
Now, Billy, if you did it this way, you said, Professor, we're just put a log on each side. And then do the log business I need to do here, and then divide through by log 3, and you'll say, Professor, my answer when I turn my test in next Wednesday is that. And all of a sudden, Billy's talking to Alexandra, and Alexandra, Billy, I got this. Are they both correct? They look different. Are both these correct? What do you think, guys? You think they are? Does anyone know a way? I don't want to get too much into detail here. They are. But does anyone know a quick way to show that these two are equivalent? So I've got to count this correct and this correct. Does anyone know how to do it? How to verify it? Yes, they are. They look different. How can you verify it? No, the professor, I think they're the same. You got an idea? Maybe not. Now let me first point out something you can't do at this point. We were finished with the problem. We got two answers, two versions of the answer. You cannot do this. I've seen students do this. This is not this. Some students get carried away and they'll say, oh, professor, that's a quotient, so why not write that like that? No way. No way, you can't do that with the quotient property. So I can't do that. Now see, got an idea that to show your classmates why, even though they look so different. Right here, this is a base 3, I think.
I think that's the formula.
And I used a base 10, didn't I?
Change the base.
Yeah, if you change the bases. If you change the bases, maybe that would work out. By the way, here's the answer that I have now. Suppose I change this. By the way, I notice the log I introduced has no subscript. It's understood to be what, base 10?
Yeah.
Suppose you take this answer here. Let's say Alexandra got this on her test. And she says, Professor, could I change that to a base 10 if I wish? You can if you do a change of base formula. Did we discuss that change of base? Monday? Let's introduce it with base 10. So then write this as log base 10 of what? 14? Over, as long as you take the log of base 10 of the original base. Are these two the same? Just do a change of base. Okay, so I've got to be careful when I score the papers. Because sometimes I'm looking for an answer that I have on my key, and all of a sudden I go back, well, hold on now, that student was correct, they just had it in a different version. Okay, so we're done with that. Shane, I think, was there another one there to solve besides that?
There is.
Oh, please say what that is.
Natural log of x
Okay.
minus 3 square root natural log of x.
Whoa, whoa, whoa.
Yep. Plus 2 is equal to 0.
Whoa. Now that's what Berkeley, Stanford, that's what they're looking for on the exam. That's the type of problem they're looking for on the exam. Now guys, look at it. Tell me something that you might want to try for an approach here. And I know I see a square root staring at me. So most students are saying, oh, professor, you got a square to get rid of that square root. I think you're going to run into bigger problems than ever if you try to do that here on this one. Let me step back and look at it. I've got a hand going up. Yes?
Does it say that you can let U be?
Okay, did I point on the handout, did I say let U be something?
No.
Okay, see? On the test, to benefit you, I will on a problem like this. Just indicate that on the side. I'll write it out for you. So you'll know it's one of those that you should do that. Now the strange thing is, I love that. What are you gonna let u be?
Square root of natural.
It is, square root of natural log. Look at this mess. It's usually that middle part for your u substitution. And he says square root L to the x. It looks messy. Now, before I jump into it and start making my u substitution, I think everyone in class would agree that the first term with his substitution, look at this. Guys, please tell me, could the first term be written like that?
Yes.
The square root of L of x, the square root squared, would that just give me L of x after you square the square root? Therefore, if I do that, then yes, with the L of x, square root of L of x, I can write this as u squared, look at this, subtract 3u plus 2 is equal to 0. I've said many times, even in grad school when I was doing all my higher math, that would make me so mad when all of a sudden the professor wrote something down into something that was so simple that I couldn't see. I didn't see it. And all of a sudden, the whole board's full, and down here, algebra 1. Take it down to an algebra 1. This is algebra 1 now. I think it's factors. Into, I think it's u subtract 2 and u subtract 1, is it? Split this up. You guys, looks like I'm considering for the u values, those. Am I finished?
No.
No. And so wait, Professor, they actually solve for x, not u. We're not quite finished. And so you're going to pick up now and tell me that u was represented as square root ln of x. So you're going to do this. Equals 2. Square root of this is equal to 1. That's true? Now solve it. Now, it might be wise now to, in the two smaller parts there, in the black, might it be wise to square both sides? So if I square this side, to eliminate that square root, square this side, I'm going to end up with ln of x, square root's gone, equals 4. Now we'll come back to it. We don't have x yet. If I do the same thing on this one, square both sides, to eliminate the square root, you have ln of x is equal to 1. Now, it would be very sad if you went through all this work, beautiful math, and all of a sudden you to the point here, you said, Professor, I don't know how to finish up. How do you get to x by itself? Am I going to divide through by an ln? No. ln of what? Just ln, the initials, ln? Take ln as something. You can't divide by ln. Can anyone tell me a fast way to see? I've got some clever, many clever students in this class. What, just by merely looking at it, is the, look at those hands going up, is the answer. Bella.
E to the power of 4 equals x.
She's got it perfectly. She said, Professor, that means this. And there's x. 2.718 raised to the 4th. This one, Bella, since you did that for us, tell us what this one means.
E equals x.
Okay, e raised to the 1st is equal to x, or just e. And those are my solutions. E to the 4th, e. We're done. Guys, making sense? Okay. Now, I think I have, let me check and see if I do have. Where did I place it here? Shane?
Yep.
That was, we got that one out of the way, and I have that marked on my to-do. We got that out of the way. Now, Shane, read letter F, and if a student in this accelerated class, this should be the scholars class. If a student can translate what's going on in that last part there, I'm gonna be so pleased. Okay, tell me, Shane, what on earth did I give you in that last part?
You asked us to approximate, and then you gave us 3 different things.
Okay, and approximate, what was the first one to approximate?
One is e to the power of 0.01.
Okay, and then next?
E to the power of 0.002.
Okay, and next?
e to the power of 0.0000, that's 4 zeros, 3.
Like that. And she said, Professor, they need an approximation for that. Mr. Park, excuse you. Let's dive right into a calculus. Now, I think some students may say, Professor, I think I know. Oh, by the way, do you think all three are approximately the same number? And if so, you've got to confirm it. Here goes. First, Shane, when you read this to me, this is like taking some values from that e raised to the x graph. Is that true, guys? Looks like it's e to the x, e to the x, e to the x. An exponential function. And by the way, guys, that function looks something like this. Is that what e to the x roughly looks like? Yeah. Not log, e to the x. And she's telling me, Professor, they want, I'm going to place one right here, guys, for a reference. I guess I got some room. There's one. They're saying, no, they want 0.01. Oh, I bring this out here. They want 0.01. They want 0.002. I squeeze that in. And then the last one's really tight. It's 0.0003. And they want to know, could you give an approximation for those? And guys, by the way, is the intersection here, y-intercept, is that one?
Yep.
What would you say all of them are close to? This one right here goes up to here, I guess. And this one goes here. This one's even closer. Somewhere in there. Are we getting close to 1? Is that true? The closer I get to 0, am I getting close to 1? So are they approximately 1 all the way across? Mr. Park, do me a favor real quickly. Find e raised to the 0.01 and see how close to 1, the graph says it should be close to 1. How close to 1 am I?
It's like 1.01.
Come again.
1.01.
1.01.
Yeah.
Now see how close this one is. See if it's closer. E raised to the 0.002.
It's like 1.002.
A little closer for the answer. 1 point something, right? 1 point something. And how about this one with the 4 zeros and the 3?
It's 1.0003.
Are they all close to 1? Now, I should call on one of my experts here. Can anyone, I should have saved this for an extra credit on the exam next Wednesday. Oh, I've got 2 beautiful extra credit problems for you guys next week. Yeah, I've got some extra credit on this test next Wednesday. Can anyone tell me a way to write and show someone in calculus what we're doing? I mean, just write one single statement to represent what is going on here.
Is it me?
Oh, that's a limit. Beautiful. Hang on. There's a limit. Now notice that's e to the x. So I'm assuming it's going to be e to the x of a function. And if I write a limit, I need to write my little subscript down here. X is approaching something.
0.1.
Now what's it approaching, you think?
0.
0. Those points she gave me is approaching 0, and we said now, that's 1.
We don't need superscript plus.
Beautiful. Hang on, just a second. Now, you're approaching 0. Now, he's telling me, Professor, maybe also you should be really specific and place a superscript on here to tell you which side you were approaching 0, right here. Which side of 0 was I on? Was it on the right hand side? So I'm approaching zero and put a superscript with what, a positive sign?
Yes.
Isn't that beautiful? And you'll see that in calc. Guarantee you're gonna see it in calc.
Isn't it true on both sides?
Yeah.
Ah, beautiful. Now you say, could I go from the other side? You think I'll get the same answer if I approach from the other side? Yes. If you approach from the left. But with my numbers, 0.01, 0.00 something, and 0.007, you see up here, all these were on the right. Is that true, guys? The ones I gave for the data were on the right, so I used a plus sign. That's calculus. Absolutely. That means that. Now, Shane, I think, is that it?
For closing. chapter
Somewhat
4,
of that, yeah, for the closing down chapter 4?
Mhm.
Because guys, I'm worried about this. Now, if your instructor says he's worried, you get worried. Because I'm worried about just constructing the test. I'm just worried about me, I know how I am, I get nuts sometimes. What type of problems am I gonna place on there, and what's appropriate, and what may be challenging, and so forth and so on. That's why you gotta look closely at this review you're gonna pick up tonight. And the solutions I sent out today for those. Guys, with all that said, here I go. Now, that chapter 5, I think you will enjoy chapter 5. It'll get a little crazy on you at times, but it's not anything like this. Oh, by the way, as I race, someone asked, maybe in the 4 o'clock session or in the office, they said, Professor, on the final exam, I know you're going to try to combine everything. Professor, can you come up with, and wouldn't it be nice, I've been working on it, but I don't quite have it yet. Wouldn't it be nice if Ramsey could just come in, your final exam, I pass the papers out to you, and you look at it, you see just one problem. And you got 3 hours. You say, oh my goodness, I'm gonna pass this with 100%. He just gave us one problem for the final exam. This is 1 page. And that's it. And I just want to say, my goodness, I'll be out here in 15 minutes and I have my A. Alexandra says, Professor, thank you so much. But what have I created? That one problem has a function where part A, part B, part C, part D is all pertains to that function up there. Where I ask you intercepts. What else could I ask you? Asymptotes. Find the inverse. Give the domain of the inverse. And then bring this in. And bring this in, that means stuff like this. Look at this. Are we going to do it right now? No, I don't want to scare you. Sine of L of X. Good luck. Try to bring the whole course in. Now, am I going to get that one problem? No, I've been working on it. Wouldn't that be nice, though? You go out and tell your friends, oh, Ramsey just gave us one problem in the final exam. We all failed, but he just gave me one problem. Yeah, we're going to see him in the summer class. That's okay. No, guys, it's possible. Start combining all this at the very end. But here we go. With the trig, which I like myself. When I gave you the handout, of course, most of you first noticed what's called the unit circle. So I'm going to do this to get started. I wrote myself a few notes here. Yeah, here we go. Part 1. Let's call these conversion factors. Now watch carefully as I do this. Now, did I have a unit circle drawn, I think, on Monday? And we were looking at some angles and the point associated with the angle on the unit circle. And I think we talked about radian measure, degree measure. So guys, right quickly, if your angle is given in degrees, and usually I like theta from the Greek alphabet. You can use other letters if you wish to represent the angle. But if it's in degrees, and they're saying, no, change it to this new measure called radians, you merely need to multiply this by pi over 180. And that will quickly transfer that or change it into now the angle in radians. I think we discussed that. Part B, if the angles given to you in radians to begin with, and you would like to go back to middle school and see how many degrees are we talking about, the conversion factor, merely multiply this by 180 over pi. And that will quickly change that back into middle school. Theta now will be in degrees. I think we talked about that, didn't we? Now this one, let me give you a quick example. Alex, I'm thinking of an angle, theta, and its measure is, here goes, let's make up one right quickly. Its measure is 5 pi over 4. And somehow we're going to work with that. Somewhere in the problem. I need to know what on earth are you talking about, Ramsey? You got 5 pi over 4, and you're saying that's the size of the angle, theta. Could I quickly, Alex, transfer it or convert it to something that maybe we could recognize? Can I use this formula? Could I convert that 5 pi over 4 into degrees? Which might make it better for us by merely doing what here, guys? Multiply that 5 pi over 4 by what? 180 over pi? True. And the pi's will cancel out. I think 4 goes into 180. Help me out. 45? And what's 5 times 45? 225 degrees. Now that a middle school kid will recognize. You're talking about an angle of size 225 degrees. Is that true? Now I don't have my circle on the board yet. I want to place that circle here shortly. Can anyone tell me though, which quadrant, there's only 4 quadrants, which quadrant, if I sketch 225 degrees from the initial, where is it going to land? Who has an idea? I heard quadrant 3, so I now know the location. It's in quadrant 3. So those conversion factors will help me to convert real quickly. By the way, I didn't show you a quick example of the other up here at the top. If, put it on the side here, here's an example. I say theta in this case was, let's use middle school, let's say have 300 degrees. And for some reason you'd like to convert that into this new measure, radians. Guys, my formula says multiply that by pi over 180 to do it. And I think that we're reduced down by 60, I think. 60 goes to this, what, 5? And here, what, 3? So is it 5 pi over 3? I did it quickly. Is it? Okay. So when I see 5 pi over 3, I know it's going to be hard at first. In your mind, you got to think, that's 300 degrees. Now, can anyone tell me where 300 degrees is located? 4th quadrant for a location. Now, before I put my unit circle on here and get started with something I enjoy a lot. 225 is in quadrant 3. When I do finally get my unit circle going for me over here, we need to determine also, besides knowing it's 225 and I'm in quadrant 3, I need to know what point on that unit circle is associated with 225. If you have the handout, it's right there for you. That handout is a reference. Do you get to use that on a test? No. That's just cute for you. You don't get to use it on a test. But I think the handout does give you right now the associated point for 225, doesn't it? And also for 300. Now, just out of curiosity, Nasir, do you have that handout in front of you?
No.
Okay, you did. Alexandra, since you're close by, tell the class 225, or 5 pi over 4, we had 5 pi over 4. What point is in quadrant 3, what point was associated with it?
Negative root 2 over 2, comma negative root 2 over 2.
Whoa. Alexander, tell me up here on this one, we got 300 degrees, or 5 pi over 3. Check that unit circle at 5 pi over 3 or 300 degrees and tell me what point was associated with it.
1/2.
1/2?
We negative root 3 over 2.
Beautiful. Now, if I were a student, I'd say, where'd those numbers come from? Professor, you're saying I can look at this right now, but you're not gonna allow me to use it on a test, so I have to know where those numbers come from. And then if I know how to find those numbers myself, not just looking at a unit circle, then maybe I can do this, okay? I don't know how many points are on there, I didn't count, are there 16 altogether? That might be 16 points on there somewhere to work with, but here's what I gotta do. And then we're gonna move real quickly. On the side here, let me draw, get some numbers for you. Let's draw that unit circle, or a circle, acting as a unit circle. And start marking a few things here. The guys on this, let me quickly do this. This is probably the center. And we'll have something like this to work with. And we're gonna call this a circle of radius 1, a unit circle. Radius 1. That means that this is 1 of its radius, radii. Now what I'd like to do with your help, and I think I started this on Monday, I see some points I should definitely know how to find myself. If this is a unit circle and we start naming points on the circle, and I'm gonna get these out of the way first. Guys, let's start over on the right there, and someone tell me, what on earth would the coordinates of the point right there on this unit circle of radius 1, what do you think the coordinates would have to be? Right here. Gotta be 1, 0. The x coordinate, the y coordinate. We're on a grid, we're on like a sheet of graphic paper. This point up here would have to be, no doubt, 0, 1. This point would have to be -1, 0. Is that true? And the one down here, it has to be for coordinates 0, -1. That's no problem. I can get those done. Now, did I have a chance, I think right at the end of class on Monday, remind me. I have other angles besides what you see up here, those numbers there. I have others I'm concerned about. Guys, there's three others I'm concerned about. I'm concerned about the pi over 6, 30 degrees, the pi over 4, 45 degrees, and pi over 3, 60 degrees? I'm worried about those. Those are the three major ones along with these. When you move into a calc class, you should be doing well. Now keep in mind, when I say I'm concerned about the 30, the 45, the 60, you say, Professor, that's all? Well, there are angles out there of size 10 degrees. Now, am I gonna hold you responsible for the point corresponding with 10 degrees? No. In fact, you don't even see it on this unit circle. There's an angle out there of size 100 degrees. Those middle school kids can draw an angle of size 100 degrees. So there's an angle out there of size 100 degrees. Now, does it have a specific point that we need to work with in this class? No. So when you go to grad school, same thing. They have to stick with this. Just these major angles here. Now to do it though, here we go. I'm gonna start out with the one I think I ended with on Monday. Make it look something like that. And guys, we'll place 30 degrees inside here, which is equivalent to, in radians, pi over 6, if you convert it. Now, I'd like to, and I think some of my students may remember what we did, I'd like to come up with now a point associated with 30 degrees. Like down here, this point's associated with 0 degrees. We'll put those in there. This is 0 degrees. This represents 90 degrees. This represents 180 degrees. This represents 270 degrees. And if I make a complete revolution, this could also be represented 360 degrees. Is that true, guys? So those are the major ones to work with. Now those others, only three, I'm worried about besides those, one of those is 30 degrees. It comes up so often in the higher math. I need then, like I did here for this one, 90, its associated point 0.1, I gotta know this. 180, its associated point is -1,0. I need to come up with the ones associated with 30. I need to name the coordinates. Does anyone recall what we did to find the precise coordinates, x and y coordinates, corresponding with 30 degrees? Who has an idea? Does anyone remember from Monday? Did we drop a perpendicular and form a right triangle? I think we did. In an effort to look at this, and we did something like this. Have a right triangle. And I know, and you know, and we all know, if I start marking on that right triangle after I drop the perpendicular, there's no doubt the hypotenuse, the radius, is 1. The hypotenuse is the side opposite the right angle. Now, do I know the length of this right here? I do not. We'll call it x. Do I know this side here? I do not. We'll call it y. That's true. Those two sides are missing. Does anyone remember what we did? And let me throw in one more little item, I'll take suggestion. If this is 90 and this is 30, common sense tells me this has to be 60 degrees inside there. Is that true? Okay, go for it.
The side that is against, if the angle is 60 degrees, the side that it looks to is one half of the, what do you call it?
Now you're almost saying it.
Of the longest side.
Okay, the hypotenuse. So he said, Professor, I remember you telling us on Monday that the side opposite the 30, in my case, this side over here is opposite the 30. If it's a 30-60 right triangle, it's always, no matter how large that triangle is, how small, it's always 1/2 the length of the hypotenuse. And my hypotenuse, thank goodness, is on that unit circle, which has a radius of 1, so it's 1. So 1/2 of 1, that's 1/2. That side's done. To find the length of the other side, I think right at the end of class, we used this theorem. Is that true? Pythagorean theorem? C squared says hypotenuse squared, that's 1 squared. A squared, guys, that's my x squared, it's missing. B, let's call that 1/2 of B. I found that earlier. Just plug in my numbers into Pythagorean theorem. I'm going to end up with 1 is equal to what? X squared plus 1/4. Subtract that 1/4. We're just doing some basic math. Take a square root. Please tell me, do we end up with radical 3/2? If I do a square root. That tells me then that the other coordinate, where am I? Down here, is radical 3/2. Now, is that going to change in grad school? No. Go on to Columbia. Enjoy. Go on to Stanford and smile. These numbers are not going to change. You see what when you get there, it's not going to change. These numbers will not change. Now, what does that give me? That gives me that the x coordinate is radical 3/2, and the y coordinate is 1/2. And that's for a 30-degree angle, pi over 6. Okay? Now, let me label the quadrants. This is quadrant 1. We all know that. This represents quadrant 2. This is quadrant 3. This is quadrant 4. We'll do something here shortly, guys. Quadrant 1, right here. If I'm in quadrant 1, this is quadrant 1 right here from middle school. If I'm in quadrant 1 and a point falls in quadrant 1, what are you guaranteed the coordinates of that point are? They're both positive, which is going to help me. If I'm moving into quadrant 2 and you plot a point from middle school and it falls over here in quadrant 2, you're guaranteed the coordinates are negative, positive. The x is negative, the y is positive. If I'm down in quadrant 3, down here, and the point falls down here from middle school, you're guaranteed they're both negative. And if you're in quadrant 4, a positive, negative. That's middle school. Is that true, guys? Now, here we go. I would, with your help, before I move into any new angles, for that 30-degree angle, I'd like to do this. I'd like to move it into the other remaining 3 quadrants. You said, Professor, how are you going to do it? I'm going to reflect either across the x-axis or the y-axis and see where it lands, and then with your help, maybe, let's see if I can get some color here, maybe discover another angle that we don't have yet. I'll try green here, guys. Now, let's take this angle. This is the angle. Let's reflect it across the y-axis. Now, if I reflect it across the y-axis, please tell me, might it look like this? Across the y-axis. So this is 30 degrees, or pi over 6. We'll call it pi over 6. Is that true, guys? Now tell me, as I reflected across the y-axis, can anyone now tell me, I have now another point I need to label the coordinates for. I have a new point. Anyone tell me, if I take this point, reflected across the y-axis, what should the coordinates of this point be? Knowing this. Am I in quadrant 2 now? So should it be a negative radical 3 over 2 and a 1/2, corresponding with this? Is it true? We've done that. Now we do, went across the y-axis, go across the x-axis. Let's go back to the blue, and now let's take it across the x-axis. It's going to be down here. So guys, if I do it down here, let's see what might be appropriate here. And see what happens down here. We're going to move into quadrant 4, and I'll make it look something like this. Now I'm at another point I'm worried about. We're getting this unit circle filled in. So guys, this is 30 degrees, flipped over, reflected over the x-axis. So this is 30, or pi over 6. Now, here's the point going with it. Now if I'm down in quadrant 4 from middle school, what should the coordinates look like for that point there? Help me out. Radical 3 over 2 stays positive. And the other's what? Negative? 1/2. And those are the coordinates. Alexandra, the only other place left is quadrant 3. So what am I going to do? I'm going to take this point or angle and reflect it through the origin. I'm going to take it directly across like this into, by the origin, into quadrant 3. Now it's going to get a little messy here. Now I'm down here. This is 5 or 6. Now can anyone tell me, this point right here, went with me. It's now down in quadrant 3, and I know from middle school the coordinates should be these. So what would be appropriate to label this point as? Negative radical 3 over 2, and what else? Negative 1/2. That's reflected from one to the other until I got through all 4 quadrants. I think I have all 4 quadrants covered now. That's what we got for that one set of numbers. Now, I need some real big time help. Let's go back to quadrant 2. Here's 30 degrees. I know to get over there, the angle looks like this. Now, I know the numbers, the coordinates are these. That's no problem. But the angle, of course, was 30 here, is 30 here also. It's 5 or 6. Can you tell me, though, from the initial over to where it landed, this is the terminal side, this is the initial side. What size angle is that angle? And the answer you give me must fall between 90 and 180. Because I'm in quadrant 2. Who has an idea what is the precise size of that angle falling between 90? Daniel, tell what it is.
I'm not sure, but 120.
120 or 120?
150.
Okay, now I'm hearing something else. I heard 150. I see why Daniel said 120. Guys, this is 30, this is 30. Is that true? By the way, from here to here is the angle I'm after. That's the angle from the initial to the terminal. If this is 30 and this is 180, wouldn't that be like 180 subtract 30 and what's left over is what, 150? Does that make sense, guys? 180 subtract 30 would be 150. So this full angle is represented as 150. I'm getting my graph all marked up here. So the angle right here, guys, is 150. Let me just place it on the side. I'm running out of space here. 150. I don't know at this point whether you guys are comfortable enough with this change. Does anyone know what 150 looks like if I go back and maybe convert it to radians? And it's probably on that unit circle. Is it 5, 5, or 6? And all they did was use a conversion factor that I mentioned over in part 1 there. 5, 5, or 6. That's that one. Now we'll do the others. Now quadrant 2, oh boy, I've got to be careful. Here we go. Now quadrant 2, we got it out of the way, it's down here, the point is, but the angle is down here, or it looks like this. That's the angle. So its size falls between 180 and 270. Who has an idea of what its size is? From the initial to the terminal. All the way around, between 180 and 270. Anybody have a guess as to what its size is? I hear 210. Now, if you say 210, I agree with that. Does anyone know what 210 looks like if I convert it by one of those conversion factors? Is it 7, 5, or 6? That's where they got that. And the next one, my goodness, is this one. I'm trying to do it in green. Starts on the initial, all the way around, and finally stops there. So that last one is in quadrant 4. The answer must fall between 270 and 360. So what size angle, guys, might it be for that one? I heard, what, 330? And if it's 330, if I convert that real quickly with one of those conversion factors on the side there, is it 11, 5, or 6? And you got it. If I don't show you where these numbers came from in that unit circle, and I do not want you ever to walk out and say, Ramsey asked us to memorize the unit circle. If you say Ramsey told you that, I'm going to find you. How about a few choice words to say? I'm not saying for you to memorize that. No way. Don't try to memorize that. You'll get so accustomed to looking at that circle though with the work coming up, you'll get accustomed to these numbers, yes. But I'm trying to show you where they came from. Okay, so don't try to memorize it. Guys, any concerns here? Now, how many angles did I say besides those that we have? We have what, 2 more? The next one I want to do, and I'm seeing how much time here we have. Okay. I may just do one more tonight. I've already done the 30, the 5 or 6. I'd like to do the same thing. My sketch is all messed up here. It's crowded. I'd like to do the same thing as I was doing here with the 45. That's another special angle we need to do. So 30 we've already done. 45 we need to look at it also. You know what, if I'm clever, well, I was going to try to erase some of this and put 45 in there. Wow. Hold on, guys. I got to get this out of the way. And then we really, 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 really do this. Let me draw one more unit circle here real quickly. Oh, wait, is this making sense the way we're doing this? The way we're approaching this? Draw one more, then this will be the last one I'm doing tonight. And wanna do more with what we see tonight. Guys, unit circle, again, just right quickly. It looks something like this. Oh, that was really good stuff. Wow. Okay, 0. Pi over 2. Pi. 3 pi over 2. And if I make one complete revolution, that's 2 pi. Pretty sure do it. Lopsided circle. Now I'd like to place inside this time an angle of size 45 degrees. And you're going to help me out here. So that looks like this. And this time it's 45 degrees. And I need to find the coordinates of that point that's associated with 45 degrees. That's another one of those special angles besides 30. I'm gonna do the same thing I did last time. What, drop a perpendicular? We'll do it. See what happens here. And let's do this. Perpendicular. I know and you know this also has to be 45. Now guys, what I'm looking for are the coordinates associated with 45 degrees, and I'm using a right triangle for help here. I know and you know also that the hypotenuse has a length of 1 because this is a unit circle. I'm looking for this. I'm looking for this. Any ideas? Or does anyone remember something special? 3060 we had something special going on. Does anyone remember anything special happening on a 45, 45, and in fact it's given a special name? 45, 45, right triangle.
Both sides are the same.
Let me again.
X and Y are the same.
Thank you, the two sides are equal. So that means I could, if I wish, if they're equal, I could call this another X. That true? The two sides are equal. It's an isosceles right triangle. If it is, I apply the Pythagorean theorem again on this. In this case, I will get, let's see, what do we get? We get c squared, which is 1 squared, hypotenuse squared, a squared, and we'll call that x squared, that's my base. B, x again, so two sides are equal. So I got 1 is equal to 2x squared. Divide by 2, I got 1/2 equals x squared. Now please, tell me, I know I gotta do a square root. Anyone tell me what square root 1/2 looks like in better form than what I have right now in mathematics? Because they do not want you to leave a fraction underneath the square root. What's the square root of 1/2 look like if you simplify it? Anyone?
1 to the power of -1.
Do it again.
1 to the power of.
No, something easier than that. What do you think square root 1/2 looks like simplified? Okay, let's do it. Let's simplify it. You could rewrite it like this. First. But then you run into an issue. You're not supposed to leave a radical in the denominator. So if you rationalize this, change it. You're going to multiply by a radical 2 to rid this thing of that radical in the denominator. You guys will end up with square root 2 on top, 1 times 2. Down here you end up what? Radical 4, which is merely 2. This is equivalent to x is equal to radical 2 over 2. Now, do I have enough to label the coordinates? I do. This is radical 2 over 2. And we have really lucked out here for a 45, 45. This is also radical 2 over 2. If I place those here, I have now another point I can work with. And this is the last one we'll do. You say, Professor, how about the last angle 60 degrees or pi over 3? Are you going to do that like we've been doing here? No, I'll just tell you what the coordinates are for it. Okay, guys, what am I going to do? We'll do the same thing I did here. We'll start reflecting. Let's reflect across we'll draw the y-axis. So guys, if I reflect across the y-axis, help me out here, and then we'll put all this together. I'd like to take this point across the y-axis. If I do, I know we're in quadrant 2, therefore now my coordinates should be what?
Negative root 2.
Absolutely, and radical 2 over 2, we're in quadrant 2. And we'll come back to that. If I now take that point across the x-axis, reflect across the x-axis like I did over there, it's down here in quadrant 4. And now I need, since I'm in quadrant 4, the coordinates based on this. What would that look like if I'm in quadrant 4? Positive radical 2 over 2, is it? And a negative radical 2 over 2, please tell me, is that correct? Yes or no? The last quadrant, going through the origin, will take me into quadrant 3 like we did earlier on the other one. And if I move into quadrant 3, hold up for me. I'm now at a point here. And guys, I'm in quadrant 3, my coordinates should be both negative, negative radical 2 over 2, negative radical 2 over 2. That's what you do with these angles. This is the last one I want to give you a setup for this. Now though, on the side. Let's do this on the side. Gotta watch my time here. I know and you know, if you now take this over here into quadrant 2, I'm talking about the angle itself is that from the initial to over there. I know the corresponding point. It's here. Can anyone tell me what size angle, because I know this is 45.
135.
I heard it.
135.
135. So on the side here, I know one of the angles is 135. And Shane, if you convert that real quickly by conversion factor, that is?
3 pi over 4.
That's one in quadrant 2. If I go back and say, yes, Professor, I see what you're doing here, now let's go to quadrant 3. That from the initial would be this angle. I know the point. Now, can anyone tell me the size of, recognizing if this down here is 45, it's gotta be, what size angle am I talking about for that large angle there?
225.
Is it 225, 180, plus 45, 225? Or better yet, if I convert that, what is it? Help me out.
5 pi over
5 over 4. And we'll have fun with this shortly here. And the last one, from the initial all the way, where is it? Down in quadrant, did we do this one?
You didn't draw it.
You just didn't draw it.
Oh, I didn't do it, did I? Okay, so we did that, we did that, we did that, okay. So we're saying now we're going into what,
Quadrant 4.
quadrant 4, down here. Okay guys, here we go. Put it like that. Are we talking about the angle or something like this? Yes or no? Please tell me what size is that large angle? It's caught between 270 and 360. Is it 315? Okay, so this angle now looks like it's 315 degrees. Better yet, in radians is?
7 pi over 4.
7 pi over 4. And that, with your professor's help, that's where those numbers came from. That's where I could just give you the handout, smile, left, and said, just look at the handout. You had no idea where those numbers came from. They came from the triangle and you doing this business. Okay, so step back. I got what, 5 minutes before the break? Are you kidding? It's break time almost already? How could that be? Okay, I got just what, 1 minute maybe? It was 1 minute. Ignacio. Here we go. I gotta show you what this circle looks better. what's gonna happen when we get back from the break. I think a good way to do this. Okay, guys, on the side here. We're doing this after the break. There are 6 trig functions that we must know and what they mean, and they're given specific names, they're abbreviated in a certain way. I bet when I start this, you'll say, oh my goodness, I recognize this from way back somewhere. I'm gonna start with the first couple. The first one is spelled this way. It's sine. It's abbreviated S-I-N of theta. They want you to use the angle there. So abbreviate S-I-N, they want you to find a function whose name is sine, abbreviate S-I-N of theta. Oh, Professor, a function is like f of x equals, and you tell me what f of x equals, you tell me what it is. Well, look at this definition. This is like a definition. Are you kidding? The sine of theta is merely equal to, by definition, these are the shortest definitions you'll ever witness in your life. The definition is y. Now, before we take that break, I'm going to do one. Billy, suppose I try this. I'm going to use S-I-N. Theta, I'm going to use one of these over here. Let's say theta was, let's say, 270. Better yet, sine of 3 pi over 2. Now, Billy, as we close down for break, if I want to find the sine, it says, please look at only the y. What was the y coordinate corresponding with 270? -1. That's the sine of 270. Next one, the y coordinate. Just the y coordinate, and you're finished. Now I've got others, I'm gonna do it after the break. The other one I should do right now, and I'll pick up the others after the break, is this one. Cosine. Spelled this way. Abbreviated this way. C-O-S. Now I want you to find cosine. Well, I can't find it until you tell me what the function is. Give me the definition. Look at this definition. It's x. Shortest definitions you'll ever witness. Now, if I should ask, Alexander, before we take that break, let's go back to 270 since I zoomed in on 270 earlier. Cosine of 270, you said, Professor, that's what is that? Well, here's 270. Cosine, if I accept the definition, cosine says the x, what's my x coordinate here? 0. So cosine of 270 is 0. You're done. Look how brief those definitions are. And we'll use those after we get back from the break. You guys, enjoy your 10-minute break. And we'll finish this up. And I also got a short quiz.